In this experiment, you're going to be verifying the percentage of ethanol in vodka using the gas chromatography with the Simplex optimization system. Solution prep in this lab is relatively simple. So on day one, the only solution that you're going to need to prepare is a 40% 1-propanol solution in distilled water. And the 1-propanol in this lab serves as your internal standard. And the solution that you'll be injecting onto the GC is a 50-50 mixture of this 40% 1-propanol solution in vodka. On day 2 of the experiment, there's a little more solution prep involved, but all you do is be preparing a calibration curve with various percentages of ethanol. So a 20 to 50% ethanol by volume percent calibration curve. And again, the solutions that you'll be injecting onto the GC are a 50-50 mixture of your calibration curve solutions with the 1-propanol solution. So on day 1 of the experiment, you are going to be injecting your vodka and 1-propanol solution mixture. And the first thing you're going to do is predetermine your temperature and pressure pairs that you'll be injecting your mixture at. As suggested in the lab manual, you want to make sure that you are picking low temperature and high pressure scenarios or high temperature and low pressure scenarios. So I'm going to use the 30 degrees Celsius with the 30 psi temperature pressure pair. So to edit the temperature in the software here, you want to go under the oven tab, and then in this degrees Celsius box, you want to just type in your temperature. So I'm going to do 30. And then here's also where you change the retention time of your run. So right now it's at 3 minutes. One thing to note is that if you are doing the 30 degrees Celsius with the 30 psi pair, you want to make sure that your hold time is at least 5 minutes. Otherwise, your compounds will not completely elute off of the column in the run time. All right. Once you have changed the temperature and the run time, now we just want to change the pressure of the column. So we want to go into the column tab here. And you can change the pressure right here. So I want 30. All right. All right. So once I have made my changes into the method, I want to save these changes. So you're going to go File, Save Method. And then you want to have the computer software communicate with the GC so you can load your method. So to do that, you need to hit Control and then Download Method. So this gets the computer talking to the GC instrument. So as you can see, when I did that, you now notice on the screen here that the text turns red. So whenever you have any red text here on the side, that means that the GC is not ready for an injection, and you need to wait until all the text is turned black in order to inject your sample. So once you've entered in your parameters and downloaded the method to the GC, you are going to need to do a prep run. So it'll have red text over here on the side column, and it will say GC ready state not ready, waiting for prep run. So all you need to do is hit the small gray prep run button on the GC, and once the text again turns all to black, you can save your sample and then you are ready to inject. So before you make an injection, you may need to clean out your syringe. The points you need to clean out your syringe are when you're injecting your first sample of the day, or when you change in between different solution types. So on day 2, for instance, if you inject a 20% ethanol solution, you need to clean out your syringe with the 30% ethanol solution before you inject your 30% ethanol solution. I'm going to make an injection here of the vodka and the 1-propanol solution. So to do this, you just open up your vial, and then you stick your syringe just directly into the vial, and you just gently pull on the syringe. And you want to wait a little bit for the solution to get pulled all the way up through the syringe. And then you can just gently press out the solution onto a Chem wipe. And since it's such a low amount of volume, this syringe only holds 10 microliters of liquid. You can just do it directly onto a Chem wipe. So you want to rinse out your syringe 5 times per solution. Like so. So you just repeat this procedure 3 more times, and then on the last time, you're ready now to inject your sample. So again, this is the 10 microliter syringe. So for your sample, you are going to first pull up just 1 microliter of straight air, and then you take your syringe and put it into your solution, and then you pull up 0.5 microliters of your solution. And then after you pull up the solution, again you want to pull up 1 more microliter of air. So the stopper of your syringe should be at about 2.5 microliters when you are done pulling up your air solution and then your air. And now you are ready to go over to the GC to inject your sample. So once you enter in your sample parameters, you want to save your sample. So to do that, you can hit Control, single run. And in the sample ID, this is where you type in your sample. So this is the vodka. And I recommend typing in both the pressure and the temperature in your sample ID. That way you can always match up your output, your data output to the sample parameters that you entered. So I did 30 psi or 30 p and then 30 t. All right. So the only other thing that you should change in this window would be the result path. So you want to again make sure that you're always saving it to a public space where all the members of your group can have access to it. So this is going to be saved under the local disk, under the enterprise drive, in the projects folder, in the 6850 folder, in the results folder. My particular sample is going to be saved in the 2014 143 folder, so save in the appropriate folder for the year that you're taking this class. And then finally, I'm going to save it in the summer 2014 videos. All right. Once you get it saved, you can hit Start. All right. So this window will pop up, and whenever this window pops up, you are now ready to inject your sample onto the GC column. So once your solution is in your syringe, you are now ready to make your manual injection onto the GC column. One important thing to note is as soon as you push the stopper to inject your solution onto the column, you're going to want to hit the gray start button as soon as possible. So you want to sync your injection with hitting the start button. All right. So you're just going to hold your syringe vertical into the inlet, and then you're going to have to give it a little bit of pressure and push down, and you want the bottom of the syringe to be completely flush with the inlet. And then once that happens, you can push down on the stopper to inject your solution And I'm going to hit start very soon after I do this. All right. And now your sample is being injected onto the column. When the sample has finished running, this is what your window will look like. One thing to note is that all of my peaks here are integrated, which is these red lines down here, but sometimes it doesn't automatically integrate properly. So if that was the case, you need to manually integrate the peak. So to do that, you need to go down here to the toolbar and click on the manual peak button. All right. And so the first thing you do is you click the new start point for your peak, and you kind of want to make sure you capture the entire window of your peak. So you want to go beyond your peak. So I'm going to go about here, and then you click the endpoint for your new peak. So we'll go about here. All right. So this manual peak window will pop up, and it says the start time and then the stop time. So these are the endpoints that I clicked. And then to add this information to your results, you need to hit Analyze Now. And it says the current method has changed, so I'm just going to hit Yes. All right. Now to print your reintegration here, you need to go to Results Set, and then down to Process. And you just need to make sure that down here in this report box that all of these boxes here are checked and your result path is saved to where you have been saving your other sample files. All right, and if I hit start, so when you have finished printing out the results of your reintegration, to inject your next sample, you need to right-click on this result review mode here, and then you want to unclick result, and then you want to exit out of your window and anything else that popped out. And now you are ready to inject your next sample. So once you have made your initial 3 injections using your pre-selected temperature and pressure pairs, you're going to now use the Simplex optimization program. And the Simplex optimization program is on the laptop right here. So there's a special way to log into this laptop. So you're going to need to do Control-Alt-Delete. All right. And then you need to click Switch User at the first login screen. And then you need to click on the left Other User option. So this would be this one. All right, and now you see 2 sort of login prompts here. So the top one, you need to enter your Hawk ID at uiowa.edu and then enter your password. All right. And then you have to do the same thing in this bottom prompt here, the exact same thing. So, and password. All right. And now you're ready to log in. All right. Once you are logged in, you need to open the Simplex program, which is this DOS box icon here. So double click. For the number of iterations to perform, you can enter in 40. You probably will not get to 40 iterations, but we're just going to tell the program to type it. We're just going to type in 40. All right. So here you enter the number of peaks in your chromatogram. So think about how many peaks you actually have, which corresponds to the different components of your solution. Enter in your optimum analysis time. So I'm going to say 4. And here's where you enter in the minimum and maximum temperature. So in our experiment today, our minimum temperature is 30 and our maximum temperature is 80. Note here that I'm trying to follow the format that Simplex is giving me. So here where it says minimum, comma, space, maximum, I have minimum, comma, space, maximum. And then notice how when I'm going from line to line, I'm just hitting enter once I'm done typing in the information. Okay, now it wants the flow rate. So in this case, we're going to be using pressure and not flow rate. And to Simplex, it doesn't matter which one you use. So we're going to do pressure. So our minimum pressure is 10 and our maximum is 30. All right, enter. All right, so here is where you enter in those 3 initial pairs of the temperature and the flow rate that you decided. So for my experiment today, I did 30, 30. So again, I go 30, comma, and then I want to space 30. All right, so it says 1 pair per line. All right, so that was my first pair, so now I'm going to go to the second line. My second one, I did 55 Celsius and 20 psi. The third one, I did 80 and 10. Okay, once I enter in my 3 pairs, I'm going to hit enter. All right, so my experiment 1, experiment 1 corresponds to the first pair of temperature and flow rate that you entered in. So in experiment 1, you want to enter in, for each of the peaks that you determine, you want to enter in the time and the base width. So the way this works is, for your first peak, you enter in the retention time. All right, and then you enter in the width. The width is listed in the last column of your results printout. All right, and now I need to enter in the second peak information. Note that it says 3 pairs per line, so I entered in the first pair. All right, now I'm going on to experiment 2, which again is the 55 degrees Celsius, 20 psi. It's also important to note that in this program, if you type in something incorrectly or make a mistake, you have to start all the way over at the beginning because there's no way to go back and delete what you've typed. So just be extra careful when you're typing in the information to avoid having to start over. All right, and now I'm going to go on to my last pair. It might be helpful to you at this point if you want your lab partner to read off the values to you if you can type them in faster. All right. So here you can see it gives you the results of the initial experiments. So again, the first 3 that we decided, and it gives us the CRF values. You want to make sure before you continue on that you record these 3 CRF values into your lab notebook because you cannot retrieve these values later on. All right, so once you've written down your CRF values, it says in this line to enter CR to begin calculations. So you just type capital C, capital R, and then hit enter. So this prompts you now to the screen where you'll see a graph. And on the y-axis here we have flow, as you can see, from 10 to 30. And on the x-axis here we have temperature from 30 all the way up to 80. And what you want to take note of now is this suggested temperature and flow rate. So it is telling me here to use a temperature of 48.8 and a pressure of 22.5. Now you will go back over to the GC and you will enter in these parameters and do your next injection. So you continue like this throughout the day 1 experiment, and you'll try to get as many iterations done as possible with the remaining time. So on day 2 of the experiment, you are going to need to take the refractive index of your ethanol calibration curve, and to do this you're going to be using the refractometer. So this is the refractometer right here. So first you need to clean off the lens. So you could just squirt a little bit of water and it'll bead up a little bit on the lens. And then you'll take a Chem wipe and just gently wipe off the lens. You also want to make sure you get the top as well, because this lid will come down actually onto the lens too. Okay. Now you can take just a plastic dropper pipette and take a little bit of your solution. And then you can drop about 5 drops onto the crystal. All right. And then you can close the compartment and make sure it kind of clicks down like that. All right. Now you want to turn on the UV bulb. So I'm just going to raise up kind of this arm here with the UV lamp on it. Now there's a switch over here on the side, and the position that the switch is in right now, the UV lamp is off. I'm going to switch the UV lamp on, which is sort of the middle position of the switch. And then the lower position of the switch is when you actually take the refractive index reading. Okay, so with the UV bulb lamp on here, you're going to peer into the eyepiece, and then you're going to use the coarse and fine adjustment here. The fine adjustment is on the side here. You're going to be using these to sort of adjust your view in the window here. So after you turn on the UV lamp, look into the eyepiece, and you can use your adjuster, your coarse and fine adjustments. And basically what you are looking for is a solid line, half circle, and you want to use the adjustments to make this half circle as clear as possible. You might also see some rainbow type colors in your circle. That's okay, but you just want to make sure that the bottom half of your circle is black, clear, and that line dissects the circle directly through the middle. Again, once you have adjusted the refractometer to your liking, you can then just take a reading by flipping the switch down and peering into the eyepiece. And you want to make sure to jot this value down in your lab notebook. And it's the top, there's 2 values when you take a reading, and you want to make sure that you get the top value, which should read about 1.35 to 1.36. And you want to make sure to write down all of the decimal places. There's 4 decimal places in your lab notebook. When you take your refractive index reading here, you also want to make sure you jot down the temperature of your reading, and the thermometer is located on the right-hand side of the refractometer. When you've finished with all of your experiments, to take care of the waste, all you need to do is dump out the remainder of your solutions into the waste container labeled GC waste.